Computers have been used in the gas industry since the early 60s. They are vital in both the technical and the commercial sides of the business. We're going to look at how one organisation, Scottish Gas, employ their computers, and we'll start with their large mainframe machines. This is the main computer room at the Scottish Gas headquarters in Edinburgh, and it's here that all their large-scale data processing is carried out. Once the customer files have been loaded, the operator can initiate a batch run which will prepare gas bills for all the private customers. That's a mass production job, with thousands of bills printed each day. And this means that there are thousands of pieces of paper, one for each customer's meter reading. It requires specialized hardware to get this data into the computer fast. This is the optical character reader. It translates the handwriting into data that the computer can read. But handling bulk data needs more than just a lot of hardware. The scale of the problem affects the scale of the software. So what are those software considerations? Head of Management Services at Scottish Gas, Alistair Beaton.
Our biggest data processing applications are the customer-orientated tasks. Take the quarterly billing of our 1 million gas customers, for example. That one application involves something like 20 million computer transactions per year. That works out at roughly 80,000 a day. And in addition to gas billing, the central mainframe computers handle the rest of the customer accounting activities of the region, as well as financial and management accounting activities. In addition to that, we have major applications in customer service, in engineering, in supplies and personnel. To give you some idea of what our investment in application software represents, I would estimate that some 500 man-years of systems analyst and programming effort was involved in producing them. At today's prices, that must represent something like £7.5 million, which is 4 or 5 times the cost of our installed mainframe hardware. And at the current time, in order to maintain these systems and enhance them and to develop new systems, I have 50 systems analysts and programmers.
This is part of the Customer Services Office, dealing with the sale and installation of gas appliances. They use the integrated appliance ordering system designed by one of the programming teams. This customer's ordered a cooker. Once the order's entered into the computer, the software takes over. For example, the order has to be validated. Does the customer actually live at this address? And the software must also allow for the cooker to be sent to a different address. Once the order's accepted, a job card is printed out for the fitter to connect the cooker. Another of the many tasks the software must be designed to handle. So how is such a system designed? Manager of Computing Services, Jim Gardner.
In a large project like this, there are many activities which contribute to its success. However, I would pick out 4 major items. Firstly, analysis. There must be a thorough analysis of all the data requirements of the system, and all the processes must be clearly defined. Secondly, design. The design of the system must be robust and well thought out. We tackle this problem by holding discussion sessions with other members of staff who can criticize the original design. In this way, many potential problem areas are ironed out at the beginning of the project.
Anybody, any comments on that now?
How many VDUs are there going to be?
Well, roughly about 3 per area, I would say, at the moment. This is just in its initial stages.
Could you say a bit more about the primary validation?
Well, what we would have online here is the stores file. The commodity code would be checked to see if it's a valid code.
Thirdly, testing. Testing of these systems must be extremely rigorous. We must remember that these systems will be implemented in all Scottish Gas offices throughout Scotland, run 5 days a week, 52 weeks of the year. Any errors could have serious effects on the company's operations. And last, but by no means least, I must stress the importance of accurate and comprehensive documentation, not only at the end of the project, but during all stages of the project.
Just a minute again, Gordon. You're saying print the job card there. Does that mean we're printing it at the area office, or are we printing it down here on the mainframe at Grantham?
I would say that we're printing at the area office. And
Documentation is always important, particularly in a large project where several people handle different parts of the design.
you know, for each job order, we would print another card. We accept it. If it's not there, we display an error.
And discussions like this help them to document the relationships between the different parts.
So what you're saying then is we'll have to have another file up online for that programme?
Yes, we have to have the Livingston Stores commodity file.
That's as well as your AP master file.
For example, there's a computer file containing information about appliances in the store. These are the Livingston stores. Here, Scottish Gas keeps stocks of appliances for the whole of Scotland. When a customer orders a cooker, enormous lifts carry the storeman to exactly where it can be found. Organising the handling of stock is another task for the appliance ordering system. The storeman uses another output from the computer, a printout, a picking list of all the appliances required for today's deliveries. It's produced by the computer from all the outstanding orders. All that remains is to get the cooker down to ground level. But how does the computer know that an item's in stock? In a large warehouse like this, stock control is a major problem. This section of the store is directly controlled by the storeman himself, but another section is controlled automatically by paper tape. This time, an automatic crane moves items from one part of the warehouse to another. The tape which controls this crane is generated by the computer, so that the computer always knows the exact location in the warehouse of every type of appliance. Store's layout is an essential part of the appliance ordering system, usually taken for granted by the operators. But what happens if someone decides to change the store's layout? The programmers need good documentation to reprogram the automatic crane. Jim Gardner.
I had a good example of the need for documentation just the other week at our Livingston Stores complex. There, we have an automatic crane control system, which was provided by the suppliers who built the store 10 years ago. My staff, however, had to take over responsibility for the maintenance of the computer system. 3 weeks ago, I was informed that they were going to change the layout of the store, which necessitated a change to the crane control computer system. Imagine what would have happened if my staff had not had good documentation, which instructed them how the crane operated and gave them details of the instructions to be given to the crane to cause it to deposit the right goods in the right place at the right time.
So good documentation is essential to be able to amend the crane control program. For large systems, program maintenance to meet changing circumstances is as important and as time-consuming as writing new programs. The crane control program was perhaps exceptional. It was over 10 years old and written by another organization. But all programs need proper reference documents so that when someone else wants to make changes, they're not stuck with just a listing. So most of the administration of Scottish Gas depends on computers. But it's not just the mainframes. There are parts of the organisation where large mainframe resources wouldn't be justified, and yet computing is still needed. This machine's a Hewlett-Packard microcomputer, and this one's an Apple. These machines are acquired as the need arises and perform a valuable service when using the mainframe would be too expensive. This one's a Superbrain. Here, the microcomputer deals with financial modelling. It prepares data for further processing by a computer bureau. And this machine's made by Cromemco. It looks after billing for large industrial customers. Although it's only a microcomputer, it handles 40% of all Scottish Gas's revenue. So small computers are making an impact on the organisation. Alistair Beaton.
With the advent of low-cost microelectronics, we could see an opportunity to extend computing aids throughout the organisation without creating possibly heavy loads and certainly unpredictable workloads for our central mainframe computers. I would also say that the spread of new technology throughout Scottish Gas is being aided by two other factors. The first of those is that many of our technical and professional staff, and certainly staff coming to us from schools, colleges and universities now, already have a knowledge of computer programming and are able to apply that knowledge to solve some of the problems without having to pose additional burdens on our already heavily occupied computer systems and programming staff. The second factor is that there are more and more powerful software packages becoming available which people can use to apply to problems without having any computer programming knowledge at all. Possibly the best example of that is word processing.
So word processors are taking over in the typing pool. In an organisation like Scottish Gas, there are hundreds of reports and documents to be typed. Word processors make this job considerably easier. These machines are really just computers, but their programs are bought from the manufacturers in a package. First, the processor makes it easy to correct simple mistakes. You just go back and make the alteration. But it has other useful features. Two paragraphs which have to be interchanged don't have to be retyped. The typist just marks paragraph 1.2 to be moved back, and then, at the touch of a key, the swap is made. The typists don't care how the word processing programs are written. They just use them to the best advantage. But some small computers at Scottish Gas are programmed by the users themselves, particularly by engineers like John Dewar.
This is an application where we're using a microcomputer to control expenditure on engineering projects. Scottish Gas spends £several million a year on contracts relating to the construction and maintenance of its gas distribution system. Therefore, it's essential that we have effective procedures to certify and control this expenditure. This is where the microcomputer comes in. It can be installed at the heart of the operation in the local management unit to provide fairly powerful local processing power. Scottish Gas has installed 16 of HP 85 microcomputers, one in each of its local management units, for this particular application. Each day as the work is carried out, the details are entered into the computer, and this does three things. It validates that the claim for the work carried out is correct. Second thing it does, it produces an evaluation which we use to certify the work against. The third thing it does is provide a database which we can interrogate at a later date to produce financial reports and indicate the current financial status of a project at any instant in time.
Engineers may be faced with a sequence of different jobs, so they need the skill to write their own programs, tailored to fit their individual requirements. If the program doesn't do exactly what's needed, the engineer can change it himself. But these small computers aren't all isolated from one another.
Up to now, we've used systems based on new technology as standalone computer systems, but our experiences with mainframes tell us that added benefits will flow if we can integrate those systems, get intercommunication between systems. And in order to carry out research into this problem area, we entered an agreement with a small British development company which has produced a new type of computer architecture based on the local area network concept, which enables the various computing resources within an organization to be connected together and accessed by means of multifunction workstations. The main points are that this system solves our basic problem of allowing different systems to interchange data, and it allows people to gain access to common databases. The second point is that it will be able to take advantage of new technology as that appears on the market. And the third point is that it points the way forward for us to entirely new forms of computer application in the future.
This is one of the workstations which Scottish Gas have introduced. It looks just like a computer terminal, and it's linked to the local area network. This station is being used for word processing. In this application, it works in the same way as a standalone word processor. But because it's linked to the network, several different people can access the information on their own screens. Jim Gardner can look at this report and make changes before it's printed out. And he can also use the system in other ways.
Now, at this point, I could proofread the whole report and make any other changes which I felt to be necessary. But before doing that, I wish to send it to my departmental head, Alan Beaton, to see if there are any changes he wishes to make to the report before it is printed.
So these workstations can supply local computing power when it's needed, and they can also provide word processing or be connected together, all of which gives the user a much wider view of what computing can mean to him. What then is the overall picture? How does it all fit together at Scottish Gas, and how do they see the future? Alistair Beaton.
Scottish Gas has proved that the use of computer technology is very cost effective and produces many operational benefits. We have a substantial investment in mainframe systems and we must protect that investment. We also want to make sure that we obtain the maximum benefit from these systems, and it is our policy to develop them further. Micros today are cheap, and this allows us to extend the benefits of computerization to a wide range of operations right throughout the organization. One problem that still exists, however, is the fact that larger organizations like ourselves need a variety of computing devices in order to be efficient, and these devices tend to be incompatible. But from our experience of new communications techniques and new computer architectures, we are confident that the problem can be resolved and will be resolved.
travel.